Good morning children. In today's class we are going to learn about normal distribution. Normal. The word itself suggests it is something normal. See, we have learnt binomial curves, Poisson curves. These curves, some curve will be positively skewed. A big increase, a sudden decrease, or a sudden decrease, a sudden increase will be there. But this normal curve will be something like a mountain, something like a steady increase and one peak point and a steady decrease. So this particular curve we call normal. In day-to-day life situations, majority of us follow only normal distribution. For example, if I take height of the children in our classroom, very short children will be few, very tall children will be few. But all of you manage to be in the middle height. That is, suppose 5 feet is the average height of this class children. So only very few will be around 5.8, 5.9 like that way. Only very few will be 3.8, 3.9 like that way. The remaining children, when I said 5 is the average, the remaining children will be 4.9, 4.8, or this side 5.1, 5.2. So we all manage to be in the middle. So tending to the average or managing to be in the middle is called normal distribution. Another example, suppose I ask you, how do I take the class? All of you will not say it's a very good class. All of you will not say it's a very poor class. Okay, so many of us do not want to give extreme ideas. We always want to say mediocre. So middle, the medium answer. Very good, don't want to say. Very bad, don't want to say. But we need to say, or we prefer to say, okay, good. So any of the ideas, any brands, whether you like it or not, when they ask, most of us do not give an extreme answer. We manage to give only the mediocre answers. That is okay, good, fair, like that way. So 50%, that is the majority in the middle, we call normal distribution. Another idea, it is a symmetrical curve. If I keep in my middle, this side and this side will be the same. So this particular exercise, we will be learning problems based on height, weight, even if your marks, if I take. Many of you may not have taken above 80%. Many of you may not have taken below 40%. All of you managed to get 60% to 70%, that mediocre level. So, marks, heights, weights, product, whenever we consider, majority of normal life situations follow this distribution and hence it is called normal distribution. So in normal distribution, what is main to identify from the questions? What is mu and what is sigma? Mu, the letter, is referring to mean, and sigma, the letter, already you are familiar with. This refers to standard deviation. So normal distribution, the parameters are mu and sigma square, mean and variance. Having this, we will go to theory questions and we will explain the concepts to the depth. Exercise 7.3, question number 1. Define a normal distribution. Now normal, as I say, remember this idea. A curve that goes slowly up, reaches a maximum point and slowly declines. So a steady increase, one maximum and a steady decrease. So this we call a normal distribution. How do I define it? It is a continuous distribution as I see the diagram. It is a continuous distribution. How to define it? So we start with x is a random variable and the normal distribution with parameters mean we call mu. What symbol we call this? Mu. And variance we denote sigma square. Standard deviation you all know sigma, and variance we denote sigma square. Since it is a continuous distribution, we must give the probability density function, which is f of x equals 1 by sigma root of 2 pi e power minus half x minus mu by sigma the whole square. What did we see in the diagram? The x value ranges from minus infinity to plus infinity. The curve will go on and on but never touches x-axis. So we say x ranges from minus infinity to plus infinity, mu value also the same, and sigma standard deviation is always positive. We shortly denote it. X follows normal, that is n, with parameters mu and sigma square. X follows n mu sigma square. Second question, define standard normal variate. When mu is 40 kg, if I take weight, or mu is 5 feet, if I take height, mu keeps on changing depending on the question, height, weight, production, profit, like that. It will be difficult for us to manage right side or left side, all that. So, keeping mean as 0, we are more comfortable. So that positive we will mark in the right hand side. Look at this diagram. Positive we can mark in the right, negative we can mark in the left. So keeping mu as 0 will be more comfortable, and that variate we call standard normal variate. So standard normal variate we denote as Z with the mean mu equals to 0 and standard deviation sigma equals to 1. Shortly we call Z follows normal with mean 0 and standard deviation or variance, that is 1. Z follows N01 is the notation. This is also a continuous distribution. So we give the probability density function as phi of Z equals 1 by the same idea, but sigma is 1. 1 into root of 2 pi, root of 2 pi. We call Z as x minus mu by sigma. In the place of x minus mu by sigma, we put Z. So this distribution reframed as phi of Z equals 1 by root of 2 pi e power minus half. This quantity we call Z square. Here Z is between minus infinity to plus infinity. The third question, when binomial becomes normal. So the basic distribution that we learned is binomial. When does it become normal? Normal is almost applicable in practical life situations. In practical life, we cannot say only 10 people, 5 people. So the number of trials is infinity. N tends to infinity. Second case, P or Q will not be very small. P is the probability of success and Q is the probability of failure. They are not very small. In practical life, no probability will be very, very small, and we can even say they will be almost near half. So the two conditions that lead binomial to normal is N tends to infinity. Neither P nor Q is very small. What is N? Number of trials. What is P? Probability of success. And what is Q? Probability of failure. Question number 4, exercise 7.3. Write down 5 characteristics of normal curve. As I see the curve, look at the shape of it. Looks like a bell. So we call it is a bell-shaped curve. And if you divide into 2 parts, at this line, I can say what is left and what is right are equal. So the line at x is equal to mu is a symmetrical line. I can say the curve is symmetrical about the line x is equal to mu. So at this line, I can divide the curve into 2 equal parts. I call the curve is symmetrical about the line x is equal to mu. And looking at the curve, this I can call, this value is the middle value, this is the average value, and this is the highest point also. So we call mean, median, mode or equal. They are all at x is equal to mu. And this word unimodal, uni means one or single, modal tells me mode. How many modes for this curve? As I see the shape of the curve, it grows slowly, reaches one maximum point. So one maximum point tells me it is unimodal. Points of inflection, which we had studied in differentiation. We here have the answer x is equal to mu plus or minus sigma. And we see the curve goes on and on, never touches x-axis. We assume they touch at infinity. This particular line, x-axis, we call asymptote. The word asymptote means they touch at infinity. So when we see the diagram or when we draw the diagram, remember the curve must not touch the baseline. The baseline here is x-axis. So we call x-axis is an asymptote to the curve. I mean asymptote is a tangent at infinity. The maximum probability, this height, put x is equal to mu in this equation. If I put x is mu, this full thing becomes 0. E power 0 is 1. Forget it. What is my answer? 1 by sigma root of 2 pi. And this we call the maximum height of the curve. So maximum probability is 1 by sigma, this height. 1 by sigma root of 2 pi. It is attained at x is equal to mu. So remember, looking at the diagram, you can remember at least 5 properties or characteristics of a normal curve. You might have this also in 2 or 3 marks. So easy points I have listed here, which you can remember to write in the exam. It is a bell-shaped curve, symmetrical about the line x is equal to mu. Mean, median, mode all coincide at this point. It is having only one mode, so it is called unimodal. Points of inflection, x is equal to mu plus or minus sigma. X-axis does not touch the curve. The curve goes on and on but never touches. Such a line we call asymptote, and the maximum probability is 1 by sigma root of 2 pi, and this we gist out for 5 characteristics of a normal curve. Exercise 7.3, question number 7. X is normally distributed with mean 12 and standard deviation 4. Find P of x less than or equal to 20 and P of 0 less than or equal to x less than or equal to 12. As I see x is normally distributed, we will write x follows n with parameters mu and sigma square. Mean we call mu, that is 12. Standard deviation we call sigma. Sigma square is variance. Standard deviation sigma identified from the question, that is 4. SD, standard deviation 4, we call as sigma. Once I know these two, immediately we write Z follows standard normal distribution with parameters mu 0 and sigma 1. What is the formula for Z? Z equals x minus mu by sigma. What is the question here? P of x less than or equal to 20. In the place of x, put 20. Mu is 12, sigma is 4. Find the corresponding z value. So x is equal to 20 implies z is equal to 20 minus 12 by 4, or it is 8 by 4, that is 2. Write this question. P of x less than or equal to 20 is, instead of x we transform z. Less than or equal to as it is. Just in the place of x I am putting z. 20 is now replaced as z, which value is 2. So P of z less than or equal to 2. For finding this, let us remember the normal curve. See, this end we mark minus infinity, this end plus infinity. It is a slow increase, reaches a maximum and a slow decrease. So when you are drawing the diagram, remember it should not touch the base axis. Normal curve goes on and on but never touches. Be familiar with drawing the curve. And this is 0 when I mark. When z value is positive, mark in the right. When z value is negative, mark in the left. So as I am marking, now it is plus 2. So I will mark somewhere here. Drop a line. My question is, less tells me shade in the left. Right, greater than tells me shade in the right. What symbol is here? Less. Looks like L. So remember, this is less. So shade in the left side. So this answer I want. So minus infinity to 2 is my question. How do I write it? This is probability of minus infinity to 2. Left side of 2 tells me minus infinity to 2. How do I split it? Minus infinity to 0 plus 0 to 2. Why do I split like this? Because total probability is 1. Total probability is 1. After 0, it is 50%. Below 0, it is 50%. Or minus infinity to 0, I will say 0.5. 0 to 2. How should I find out? Standard normal distribution table. We have minus infinity to plus infinity. When you want 0 to a particular z value, you can refer this table. For example, if my question is 0 to 1, you must check under z 1. So 1 under 0, my value is 0.3413. Try out for 1.25. 1.2 under 5. So 1.2 under 5, my answer is 0.3944. Check one more value, 0.53. So 0.5 under 3. So 0.5 under 3, the value is 0.2019. Like this, you can see the table up to 3.99. Further, you are given 4, 5, all that. Answer is always 0.5. Any number beyond 3.99, answer is always 0.5 only. Now my question is 2. So under 2.0, under 0. So this is my answer. 0.4772. So this table gives me area from 0 to a particular number, that is z value. 0 to 1, 0 to 2. See, the table ends with 3.99. That tells me the remaining is a tail portion which is almost negligible. So up to 3.99 we can refer the table. Now what is my question? 2. So keep on checking. 2 is coming here under 0. My answer is 0.4772. 0.4772 is for 0 to 2. Add and tell the answer. We want both together. So if I add it from here to here, it is 0.5. 0 to 2, it is 0.4772. Total 0.9772. Those who find to write this difficult, you can use the shortcut method. From the diagram, you can immediately write it. But this is a better presentation. Minus infinity to 0, we say 0.5. 0 to 2, we refer to the table and we found out 0.4772, adding which we get 0.9772. Second part of the question, P of 0 less than or equal to x less than or equal to 12. How to do it? When x is 0, z is equal to, what is the formula? 0 minus mu. What is mu value? 12 divided by 4, or I get minus 3. When x is equal to second value is 12, 0 to 12. In this formula, put x 0 and get z value. Put x is 12 and get z value. Z is equal to 12 minus 12 by 4, that is 0. The next step, what is the question? P of 0 less than or equal to x less than or equal to 12. Change it as P bracket and all, copy as it is. Instead of 0, I find the corresponding value minus 3. Instead of x, z. Instead of 12, I will put 0. Given question is x between 0 and 12. I change it as z between minus 3 and 0. Again, draw the diagram. What is the diagram? We draw a baseline and we draw the normal curve. Remember, it should go near and near but never touches. This side minus infinity, this side plus infinity. In the middle, we mark 0. Now my question is minus 3. Where minus 3 will come? Left of 0. Mark it here. Minus 3 to 0. This is the shaded portion. So my question is to find minus 3 to 0. Even if I say negative value I cannot refer in the table. Change it as positive, because by symmetry, what is left and what is right are equal. So instead of minus 3 to 0, I can replace 0 to 3. Now 0 to 3 means I have to refer to the table under 3. The same table we have taken. My question is 3 now. So z value I keep searching. It is 3 under 0. So 3 under 0, it is 0.4987. So the answer is 0.4987. That is the final answer.